Hi, everyone. My name is Zach Penrod, and I'm the marketing manager with Inmotion US, part of the Zoppi Group. I'd like to welcome you to the session today, taking a look at cybersecurity. As electrification and interconnectivity continue to transform the industrial and off-highway sectors, the need for robust cybersecurity has never been more critical. It is imperative that companies develop a cybersecurity mindset. I'm thrilled to introduce my colleague, Alexander Sjöberg, the cybersecurity manager at Inmotion. Alexander brings a deep expertise in securing electrified systems and ensuring that the next generation of industrial and off-highway equipment is designed with cybersecurity in mind from day one. As you go through the session, please feel free to use the Q&A function at the top right of your screen. And finally, the session will be recorded and available for you to view after. And with that, take it away, Alex.
All right. Thanks, Zach. So welcome to this, at least for me, very interesting topic. So a three-course journey into the cybersecurity mindset. So, and I think we should just start directly. So what is cybersecurity? Well, I guess the scope of this question is rather broad, right? So, but I think it's worth just reflecting a bit around this question. So, I mean, you can ask yourself, what does actually cybersecurity mean for you? What does it mean for your organization, for your team? Are you a team working with this question? Is this question brought up on high-level management level, or is it just handled in some small part of the organization? But I would say, at least for it's probably true for engineers, at least the cybersecurity topic is more or less only filled with technology, right? So speaking of cybersecurity and technology, we often get to hear about cryptographic methods or methodologies and how we can ensure the security by that. And of course, this is an ironic comic of engineering, maybe joke, but still, I think it's we can use this example to actually make some sort of analysis and then bring in some context to the cybersecurity or what it actually entails. So, looking at this ironic example, we can start with the laptop. So, where did that come from? So, was it forgotten on the bus, or was it stolen from him directly, or was someone breaking into the office and reaching it? And also, they're targeting one person here, right? So maybe it's a specific person. So maybe it's a specific role with specific responsibilities. And also, if they already know that, they all probably know what type of information they are looking for in the computer, right? And this is also sensitive information in some sense. So it could lead to an attack. So we need to take the holistic view on this and think of it from a broader perspective. And then we also have, of course, the more maybe commercial question here. So how much did we actually spend on our solution? Because this was obviously cracked by a $5 branch. So the holistic view, and also put something in context. But what should we do then? How should we actually get this mindset or this way of thinking in our organization? Well, I'm happy to say that you will get all the answers you need from these sessions. I will reveal the perfect recipe to a perfect implementation of cybersecurity. Well, not really, because it's very dependent on how you work and on the organization, right, and what you're doing. But I will try my best to inspire you, at least. So this presentation or this session will be around food. No, okay, that will be an analogy. But I will try to put together a three-course dinner here, and to inspire you to see maybe cybersecurity with another pair of eyes, or maybe get a different approach, and maybe also think that this isn't impossible, right? We can solve this. So let's start with the appetizer. So this is the sort of the first dish. It's the one setting the stage for the rest, right? So we have the level of ambition. We can see if someone is more into details or if we're looking for some completeness, right? So this will be the why. If we're representing the why, how do we actually implement the why, the understanding, the purpose, a common view on why it's important with cybersecurity topics. Then the main course, the how. I mean, this is actually, it could be served alone, right? But it's better maybe with the two others as well. It becomes more complete. But then we need to answer the questions. How should it be served? How it should be served on a flat plate or on a deep plate, or should it be warm or cold, or should it be small or big? It depends on the other ones, right? And then last but not least, the dessert, sort of the sweet jewel here. And this will represent the what. So what do we actually, what do we end up with? What does the solution look like? So we will see some examples maybe, or an example on how we can handle the risks, for example, how we end up in some sort of technical requirements. So I hope you are you are not too hungry, so you can hear me out here. So, but the chef for tonight is me, Alexander. So I started at Inmotion at 2017, and has been around as a software developer, and then also as a department manager, and have worked with both automotive application and industrial application, or material handling. And besides that, I'm into playing some music, revisit my rock and roll dreams, making some food, and also go away on adventures with my family and friends. But enough of me, and back to the food. So the why. Okay. I mean, why is cybersecurity really necessary, or why is it an important topic? Well, it's stated in the legislation, right, or in the regulation. So it must be obvious, and it's also the regulation itself has resulted in a bunch of standards, especially the one for automotive. But we're still waiting on some more guidance for machinery directives. So some more guidance needed for the off-highway applications. So why can't we just use the regulation then? Can we just send it to our team and then we will be compliant? Well, I have not seen that working yet, and maybe you don't have either. So we need to look for something else, and it's actually stated already in a bunch of standards. And what I'm talking about is the culture. So we need to work a little bit more with the culture to establish the culture around this. So what is culture then? Well, I have consulted my friend Copilot, and I got the answer that sounds like this. So culture refers to the shared belief, values, norms, customs, behaviors, and artifacts that characterize a group or society. So here we have the team, the department, or in best case, of course, the whole company, right? So continuing, it encompasses everything from language, religion, cuisine, social habits, music, and arts, and the way people interact with each other and their environment. And the result then, culture shapes how individuals perceive the world and their place in it, influencing their actions, thoughts, and interaction. So by working with setting common values, stating good behaviors or accepted behaviors, and we can influence, the organization to speak the same language, and also to influence on their actions, right? So we get something that can think and something that can provide solutions and also decisions on its own. And for me, at least, that sounds sustainable. So I think this is something that we need to focus on a little bit more than maybe the technical parts, at least. And of course, this part is maybe not that easy because we're talking about people, right? We are working with people, and this is maybe some changing of behaviors, and that takes time. It's a lot of energy, but it's not impossible, right? So we can build something here. And I will not give you the perfect answer to how you should do it, but at least we can sort of investigate maybe a common scenario on in different companies where maybe you don't really want to be. So, not the company, but in the situation. That's what I mean. So let's say we have the scenario. You have an appointed cybersecurity manager, and he or she will sort of drive the change here into the cybersecurity. And what we don't want to do is to throw requirements or unclear statements into the team, right? So we will not just say that we, from one day to another, we are dealing with secrets, but we cannot really talk about them because they're secrets and we don't really know how to handle it. But please stay calm. What will happen? Well, on one side, you will have a team maybe that don't do anything. They become sort of, they cannot make any decisions, and they will sort of just not stop working, but they will be really slow because they don't want to do wrong, right? And then maybe you have another team that just, okay, whatever, and that just continues as business as usual. And then you actually could be leaking secrets, even though you want to, even though you don't want to. And another thing here is when you come to solutions. So we don't want this one-man show, right? Because cybersecurity will for sure affect a lot of functions within your company and in the actual product together with the customer. So we need more than one person's view on this, right? So with the solutions must come from a lot of functions, and this is not new. This is how we want to work with almost everything. Problems solving, right? So I guess what I'm trying to say is this is not a surprise. So stay with if you have this as a mindset, or if you have this as a philosophy, stay with that one, because that is really powerful. And I also want to say that I'm sorry, all cybersecurity manager, it must be less design and more facilitation. And that is a key here. So continuing, so also use relevant use cases and examples. I mean, now I have a pretty old example here when two experts hacked the Jeep vehicle, the SUV. So I know it's old, but still, I think it's valid, and I think it says that, or it tells us that something hazardous can actually happen if we don't think about the security, right? And also, I mean, you can have other things like intellectual property that you need to protect in some way, or maybe some other sensitive information regarding your customers or design, or I mean, could be anything actually. But what I'm trying to say is you should not use the relevant use cases or examples to scare people. We should use them as an example of what could happen and how we need to prepare. We need to prepare for these scenarios, because saying that we will be 100% secure, I would argue that that is not really what you want to do. But you will need to be prepared, because time is crucial, and when something happens, you need to act fast. And also, don't forget the first example as well. It's even though it's a funny one, I think it could be used and to show that there is a holistic view on this. That we need a holistic view on this, or a holistic approach. So the why, that was easy, right? Let's go to the how. So how do we implement the regulation and then the ISO standard? I mean, of course, this could be like just business as usual, just another ISO standard, right? But it seems to be that when this turns up and we try to, okay, maybe I'm generalizing a bit, but when trying to incorporate new standards and new way of working, we're trying to hide a little bit behind the gap analysis. And I just want to mention that I'm not saying that we shouldn't do gap analysis. I mean, that's a perfect method to actually get a good understanding of where we are and what sort of the gap we need to close, right? But it's not the change. And the problem also with just digging and try to identify this gap is that you can dig for quite some time, and you can sort of increase the scope very much, instead of taking a step back, focus on the purpose with this ISO standard or the regulation, focus on the targets, the goals, and what are they actually trying to achieve here, and how does that fit our organization? What do we need to do to fulfill those goals? Of course, at the end of the day, you need to fulfill all the work products and all the details, but I think maybe we shouldn't start there. We should start by looking at the purpose. And just to give you an example, now I don't know how many of you that are working within the product development, but I assume that most of you do. And product development, and also maybe on the vehicle side or the OEM, we already have an established development process, or usually we do at least. And in that, you will most likely already work with risks. And what the regulation says, and also the resulting standard is, I mean, this is a lot of things, but one of the things, one of the requirements is that we should have some sort of risk-oriented or risk-based approach or development process. And if we already do that by asking ourselves, have we introduced any risk in our design here? From a reliability perspective, we can do exactly the same thing with cybersecurity, but we just ask ourselves another set of questions. So early in the design phase, do we have any assets? Do we have any information asset that we need to protect? And what are the risks? I mean, what are the risks? What functionality do we have, or do we require from our product that sort of are dependent on these assets? And then at the end, how do we ensure that all these measures that we have sort of introduced into the product, how do we ensure that they are enabled so we can actually claim that we have done what we can do to fulfill our goals? And then, of course, in the middle, we need to ask ourselves, have we introduced any weaknesses somewhere in the design? Taking the system architecture, in this example, software architecture, and just ask ourselves, do we have any weakness here? So that would be one approach, and use what you have. And I think introduce another set of questions. So finally, the cert, right? And now we are going to into the sweet part of this 3-course meal, and maybe it becomes a little bit more technical now, but I think this part is very much inspired by the threat analysis and risk assessment from the ISO 21434. So it's the cybersecurity for automotive standard. And just to give you an example, what we need to sort of think of when we are designing the system, and how we sort of work so we don't end up in this situation where we have a product with our sort of main or core functionality that has been sort of limited so much by security features, so it cannot be used anymore. And so I think the key here is to hold on to the core functionality and the user experience. And we need to think about that when securing the product, because, of course, security and flexibility will not go hand in hand, right? But still, we need to be able to use the product, because there is a reason for why the customers are buying our products, right? So what should we do then? Well, so let's start with looking at the product that you are sort of designing or putting requirements on. And here we have an embedded system with a lot of interfaces, a nightmare from a cybersecurity perspective, maybe. But you shouldn't look at this as a physical sort of representation of a product. It should be more like looking at the functionality related to these different ports. So first question, what operation environment are we actually designing this product for? So what type of application, more or less? So if that is not possible to answer, well, take a generic one, or okay, it's maybe not generic, but as some sort of a basic application that represents maybe as many as possible of your use cases that you already define. And then if you say that you're going into a new business area, for example, a new segment, of course, that will be some sort of an insecurity. But that's why you shouldn't sort of bring in an application that is too specific, because then you have designed the product or the security parts of the product towards a specific application. And then what interfaces do we have? And when I say interfaces, I would say, yes, of course, you can look at the CAN port or the Ethernet port or the wireless communication. But I think the physical or the functional representation is very much important here. So let's say what is actually utilizing the CAN port. So we have internal vehicle communication, for example. We have maybe some software download or software update. We have parameters that should be calibration parameters, for example. So look at those functional blocks and see how are they actually, how do we secure them if they are sort of handling our assets in some way. And also think about which interfaces do we actually own, because looking at the port, for example, and maybe the internal communication, that is very much requirement, or that's designed and specified by the vehicle manufacturer, right? So in this case, we shouldn't maybe put so much time in trying to securing that part as much, but maybe we can look at our sort of generic basic application and also just see that, okay, we need to put some sort of technical requirements here so we can be able to maybe support some best practice cryptographic methods or something like that in according to any standard. But I think we shouldn't try to solve the problem all the way, because it will be changed, because the customer will always have their sort of interpretation and their design at the end. So now we have the item, we have the boundaries in terms of interfaces. We know the operation environment, so how it should be used. Now we need to take a look at what we actually need to protect. So this is just an example. So here we have a bunch of artifacts or entities that we think that we need to protect at least. And looking at firmware here, it's actually related to all these security sort of categories. So it's actually confidential from maybe an intellectual property perspective. We need some integrity of the firmware, because we need to ensure that the correct firmware is downloaded in the product to actually make the product work as intended. And then the availability. If the wrong firmware is in the product, it will not work at all. So, and that would be a sort of availability problem. So here we have an example that is related to all of these categorizations. And then also we have, for example, keys, cryptographic keys that maybe are purely confidential. Just an example. So now we have what we actually need to protect, and we have the functionality. And I would say I would recommend to think about what we need to protect, and we need to think about what is actually to what level we think that we need to protect this, because this will set the scope for the security measures that we need to implement later on when we look at the risks. So, here's all the bubbles. So what do we need to protect, and what impact will it have on security? So confidentiality, integrity, and availability. And then when we have done that, we can go to the threat modeling part. So sorry for this picture. It's generated, and it didn't become as I wanted to, but at least please use it, and please look at it as from a flowchart perspective. That is a lot of things going on here. And I think this will represent a very complex sort of modeling of the threats that is sort of related to our product and related to the system. So this needs to be done, of course, to also quantify the risk. But we need to ask ourselves here: do we know what sort of attackers we are dealing with here? Because if we are in a vehicle system, maybe we are more talking about users that want to, I don't know, get more power out from this unit to actually go faster or go, I don't know. It could be for any reason. Instead of sort of securing the system against hackers that want to get into this device, because we have so many secrets that can be used for more sort of hazardous things. Because this will also set sort of the stage, or set the level of ambitions in relation to risk, and also in relation to the technical requirements later on the product. So here we can adjust the scope, and also ask yourself: do we have any predefined examples? I mean, as I said in the beginning, we have examples with something that is, or for companies that have sort of been they have been attacked with a successful attack. And can we use that in some sense? I know in the automotive side, we have the regulation called R155. I think, and that is there we have tables of threat paths, for example, that we could use in this analysis and just incorporate as they are. That is something that we can think about. And then also, when doing that, do we own the complete path here? So when we integrate this in a system, I mean, taking COM, for example, so the communication network. So do we actually, can we secure that at our end, or do we try to solve something in another part of the system? So we should not try to solve too many problems in the system, right? But we at least need to think about what can we do at our end, and what security do we actually provide into the system. So having the item, the boundaries, we have what we need to protect, and the functional representation of the product. And now we have the threats and how the likelihood of they actually happening, and based on what kind of attacker we are sort of targeting here. We can use it in the process for analyzing the things that we need to protect in relation with the functionality that we have, and how it's actually utilized the assets that we have already defined. So, for example, software download. How do we make that secure software download, right? So it needs to be handled in some way because of the risk decision. There can also be risks that we are not really, we can live with. So that is also a decision to make. But we need to quantify the risks based on the functionality that we have or are designing for. And then at the end of this process, we will get to the state where we have some sort of achievable goal with the product, which then later on can be broken down in some technical requirements. It could also be broken down in other requirements more related to process or guidelines or whatever it could be. So whatever we need to do to fulfill these goals with our product, so to say. And I would say, once again, this is very much about facilitation. So get to know the process, get some knowledge, and facilitate and get all the technical knowledge about the assets, about the functionality from the experts, right, that you have around you. I think that is the key point here. So doesn't sound that difficult, right? So proceeding, when we have the technical requirements, we have sort of we think that we have a requirement on or requirement specification on the product or on our sort of way of working or processes that sort of fulfills the goals. We start to develop, and we start to sort of allocate this functionality to different parts in the system. And now we get into a more maybe philosophic part of this presentation. But the next scenario or the next stage will be looking a little bit on how to integrate security then in the complete system. So this picture will represent the lowest part of the product. I assume it's the lowest part of the product, and then also where you have security and the product itself, and then the vehicle system. So when you have done your analysis, even though we have looked at the product as an item, we can see that the functionality that we're talking about, the functional representation, and also all the features that we need to do or the measures that we need to add in the product, they are actually related to the lowest part. I mean, the component, the microcontroller in this case. So then we will implement sort of the library of security measures in the microcontroller, and what we get is a secure component, more or less, with the instruction. How can we use this to actually enhance the security of the product, and then also some goals fulfillment, and maybe some claims. If we don't fulfill all the goals that we have put on this part of the product, we will need to sort of transfer the risk, right, to the next level. So then we go to the product, and then we see, okay, do we have any additional risks here that we need to take care of on the product level? Maybe we need to add some customer-specific requirement. Maybe we have dual microcontrollers for some reason. Maybe we need on product level to add some security features due to the communication between the microcontrollers. This is just an example. And then we are sort of complete on the product level, and then we have the instructions, we have the goals and the claims, and then we integrate in the vehicle system. So, and then we will have exactly the same story once again. So, what security is provided by this component or this item in the vehicle system, and what do we need to do to close the gap to reach the rest of our goals, so to say. Maybe we need to put the segment between them, or isolate the internal communication, for example, through a secure gateway, or what could be anything. But still, then we sort of put the last sort of security features on the vehicle system, and then we sort of have built up the system with different layers of security. So, and of course, in the bottom here, we have infrastructure. And that is something that I almost forgot it right now. I can be honest. And I think we usually seems to focus really much on the product itself and maybe the vehicle system. But the infrastructure to handle all this is equally important, because we will most likely have some more complexity in our product and in the configuration of the product, and also outside the product, right? So we need some good infrastructure to actually handle this, and to not forget about the user experience. As I said earlier, this product need to be, functioning as before, but a little bit in a more secure way. And then we need to solve some of these problems in the infrastructure with tools and other things that we could think of. So a lot of talking here. So closing up to the end then, I would just summarize what we have gone through. It's first of all, maybe on the high level in the organization, build your cybersecurity organization on a common culture or a company culture with a common understanding, and that we have the same language, we have the same values, and we have accepted the behaviors that is needed to actually ensure that we have that we stay secure. And I mean, cybersecurity cannot be handled in a small part of the organization. It needs to be a question on multiple agendas on all levels in the organization, from my perspective at least. Gap analysis, we should definitely do gap analysis. I mean, we need to quantify the gap, but that is not the change. So don't focus too much on the gap analysis, because we have things called tailoring also of the processes. And I think it's better to look at the purpose of the ISO standards or the process that we want to implement. And in this case, and with the examples that I had also, the risk-based approach. Well, how can we implement that in something that we already do? Of course, you need the competence to ask the correct questions, but that could be brought in as long as you can facilitate your own process. That's not problem to find the competence, or maybe it is because everyone wants to solve this right now, but still, you get my point. And in the product design, I think it's important to hold on to the product, the interfaces, the functionality, the functional description, so we understand what we need to secure. And also, don't forget about the usability here, because it can become real complex quite fast. And if we need the complexity, we also need to handle it in some way. So the infrastructure is key. And then the last bullet, the maybe more philosophical part, and maybe more related to building a security platform and stuff like that. But integrate and build the security in layers. So secure the component, and then you introduce it in your product. Maybe you have multiple products, and you can introduce the secure component in the product and see what happens. What do we need to do now? What do we need to add? And then it's integrated in the ecosystem. I know there will be a lot of customer requirements pushed into the in the development organization, saying that we need this feature and this feature. Of course, I know that. But if you have the goals, if you know what sort of key sort of achievements that we want what we want to achieve with the products, I think you can argue and handle that in a better way. Otherwise, you might end up in implementing all those technical requirements. So good luck to everyone, including myself. We are also in the same boat, right? We are on the same journey. So let's help each other to make the best of this. And I think that's the final part. So dinner is ready. And if you want to discuss this further, don't hesitate to add me on LinkedIn or contact me there. And I will happily elaborate in this area a little bit more. Thanks. Zach.
Thank you very much, Alex. It was quite an enlightening presentation. I do have a few questions for you that have come in. So we'll start with, through your presentation, you called out the regulations for on-highway vehicles, but it doesn't seem like there's much guidance available for off-highway applications. So where would you recommend that somebody start when waiting on the requirements to come through?
I would say, looking at the guidance here will be maybe a standard or something like that. That's how I interpret the question. So, and of course, we're waiting on some more guidance, yes. But I think looking at the regulation and how it's actually stated, and maybe some more of the requirements that are put on the organization, I would say that all these stuff that I have brought up to, like a risk-oriented approach, for example, and I think that is something that we can start working with already now. And most of us, I assume that most of us are already doing that. So just bringing in the correct questions, we can sort of develop that into incorporate cybersecurity topics as well. And then, of course, the culture around this starts thinking about how we should handle. Now the information security sort of regulations has also been around for quite some time now. So I think most of us is already thinking about this in maybe some other parts of the organization or maybe on a general level. But for products, I think it's still valid to start with looking at the risks, find some inspiration on what sort of attacks we're talking about, start modeling, start trying out things, and look at what sort of requirements would we end up with, and also maybe also state the questions that we have, so we can bring in the external competence needed. So and get the answer to the correct questions. So the risk here is key, I would say. Identify the risk. So start with that and work with the culture.
Okay, thank you very much. You had mentioned the culture of common understanding, and there's a saying about too many cooks in the kitchen. So if everyone should be involved in the process and finding solutions, what kind of risks and different interpretations, what would that do to increase or decrease confusion?
Of course, there's always a risk if you sort of when implementing an ISO standard or a new way of working, if we just provide the material and then push the requirements on our teams or the organization, saying we require you to fulfill this. Of course, then you will get in the situation that that is described in the question here. So, and I think key here is still facilitation. So we cannot sort of skip that. We need some expertise within the standard, and that could sort of help us to facilitate these sessions where we come up with the solutions and come up with our values and how we should interpret the standard, because otherwise it could be, as you said, a different many different views on this. So bring in the expertise of the standard, but I think facilitate more than design or decide. I think that is key, at least from my experience. I think that is, and also if you have the expert doing everything, setting the stage, then you also will have the dependency to that person, right, to that role. So, and that is also maybe not something that we don't need to create or some sort of a bottleneck, but also risk, right, in executing our project. So I think facilitate, bring in the expertise. I think this will be easy ride.
All right, thank you. And then the final question that I show here right now, regarding the threat analysis and the risk assessment, can you maybe just reiterate a bit for the audience and those who watch this later, the importance of that and kind of where some of those risks and threats come from?
Yeah, we can. I would say that it's the method itself. So I think these slides are very much inspired by, as I said, the way of working in or what is stated in the ISO standard for cybersecurity in automotive. But I think it's really valuable. So and the method itself is not sort of required by the regulation, but it's a very structured way of actually quantifying the risks. So but we need to limit the scope. So we need to stay with our item. So we need to stay with our item, our interfaces, and the functionality that we have sort of designed the system for. And we also need to be very careful when deciding what we need to protect. So I think this crucial step, they are actually they have their own work products in that standard, and we don't know how it will look like in the upcoming ISO standards for maybe material handling or industrial applications. But still, we could assume that they will think something about handling the risk. So, and what should we then perform the risk sort of analysis on? So, stay with the item, have a functional representation of your item, and basically also your component, and then quantify the risk by using some sort of a threat modeling method. I think that is sort of can be used for almost everything as long as you limit the scope. Then you can argue if you need a goal for the product, or if you can just derive the technical requirement directly from your risk analysis. I'm not so much. I don't have any opinions in that, but I think it's a rather nice idea to also easy to communicate the goals more maybe than technical requirements. So those are sort of the steps, and then there's a lot of other things going on here. And if you want more details on that, I recommend you to look at that standard. But otherwise, we need to sort of wait for the requirements on maybe more industrial or off-highway applications to see where we end up.
All right, and then before we wrap up, I do have one additional question from myself. So it's not in the Q&A panel here, but I've noticed some AI images in your presentation. So can you maybe comment a bit on what role AI and its kind of advent can play on cybersecurity, whether it hinders the progress of it or helps the progress of it a bit?
Well, I don't dare to say too much because I haven't investigated that much. But I mean, it's of course it could be used for, as everything with AI, we can use it for both good things and also bad things, right? So using the power of AI to find attack paths and to crack or to hack security measures, I think that is obvious that it could be used for that. And how successful they are, I wouldn't dare to say something about that. But taking a look on the other side, I think it's also valuable to use to see what can we use to actually enhance the security. So, for example, you have validation techniques related to or called penetration testing or maybe fuzzy testing. And those, I mean, using AI for that sort of testing, when you more or less, it's not requirement based, you just need to apply maybe some special knowledge, or you need to just test out random things that is related to this sort of item that you're analyzing. And then AI can become really powerful as well. So I think it's both enhancing security on maybe the validation part, also helping us maybe writing requirements later on. But then, of course, it could be used to also extract this information and to create the attack path for our attackers. So I guess it's it's a two-side coin here.
Yeah, very, very good answer. So that wraps up the questions. Alex, on behalf of the Zoppy group here, I want to thank you for taking your time to present. For everyone in the audience, please remember that these sessions will be available as recordings later on. Thank you very much, and have a great day.